learn how to organize data using catalog, schemas, and volumes, upload datasets from local storage and external sources, and create delta tables for efficient querying. By the end of this demo, you will gain hands-on experience in managing data in Databricks, ensuring seamless data organization and accessibility. By the end of this demo, you will be able to identify components of Unity Catalog and explain its role in data organization, demonstrate how to create catalogs, schemas, and volumes for structured data management, execute dataset uploads from local storage and external sources into Databricks, construct delta tables from CSV files to enable efficient querying and data processing. In order to follow along, you will need a workspace with the Unity catalog enabled. In order to follow along, ensure you meet these technical requirements. You need a serverless compute cluster. Let us start with this demo. Open this notebook in your Databricks workspace. Go to the Connect option at the top and select the serverless compute cluster. Wait for the cluster to get attached to your notebook. Now our notebook is ready for execution. Let's start with the first step. Let us start by importing the necessary libraries and modules for performing the required data operations within this notebook. These libraries provide the tools for file manipulation, data handling, web requests, and working with PySpark data frames, enabling seamless execution of the task ahead. Run the below code to perform this operation. Now, our cell has been executed successfully. Let's move to the next step. Before running any commands, we must configure input variables for managing Unity catalog resources. These include catalog, schema, and volume names, along with the volume and working directory paths, ensuring consistency across operations. Run the below cell to perform this operation. Our cell has executed successfully. That means we have configured our input variables. Let's move to the next component. Managing and configuring Unity Catalog resources. In this section, we will perform tasks related to managing Unity Catalog, focusing on organizing and accessing data through its three-level namespace. We will learn how to work with Unity Catalog's three-level namespace to organize and access your data effectively. Then, we will create new catalogs, schemas, and volumes. Select default catalogs and schemas, and define the catalog setup configuration. Before we go ahead, let us first understand the Unity Catalog's three-level namespace. Traditional SQL uses a two-level namespace, but Unity Catalog introduces a catalog as an additional level for better data segregation. This helps organizations to separate data by business units, like SDLC environments, which is for software development lifecycle, or sandbox datasets. In traditional SQL, tables or views follow a two-level namespace, which could be like select star from my schema.myTable. However, in Unity Catalog, tables or views follow a three-level namespace, which will be like select star from my catalog.myschema.myTable. To simplify queries, you can set default context by running queries such as use catalog my catalog, then use schema my schema. These two queries will set your default catalog and schemas so that you can directly run operations on your table. Let's move to the next part. Let's create and manage catalog in the metastore. Run the below cell to create a new catalog in our metastore. Our cell has executed successfully, which means our catalog is created. Following this create statement, let's observe the effect by clicking the catalog icon in the left sidebar to access the Catalog Explorer. To witness the effect of the above statement, let us right-click this catalog option and open it in a new tab. Switch to the new tab. This is the Catalog Explorer. We can see that there is a new catalog present in accordance to the one we just created. Let's go back to our notebook. Let's move to the next step. Run the below cell to set the newly created catalog as the default catalog. Our cell has executed successfully. Now any schema references will be assumed to be in this catalog unless explicitly overridden by a catalog reference. Now let's continue and create a new schema. The concept of a schema is unchanged by Unity Catalog. Schemas contain data objects like tables, views, and user defined functions. With a new catalog established, now let's go down a level in the hierarchy and explore how to create and manage schemas. Run the below cell to create a new schema in our catalog. Our schema is created successfully. Let us analyze the changes. Go back to the Catalog Explorer tab and refresh the Catalog Explorer. We will now notice that our schema has been created within our catalog. Let's go back to our notebook. Now, let's move to the next step and set this schema as the default schema. Run the below cell to set the newly created schema as the default schema within its catalog. Our cell has executed successfully. Now, any data references will be assumed to be in the catalog and schema we created, unless explicitly overridden by a 2 or 3 level reference. Let's move on and create a volume. In Unity Catalog, a volume is a storage location within a schema used for managing unstructured and semi-structured data, such as filters and datasets. With a catalog and schema in place, let's go a level deeper and explore how to create and manage volumes. Run the below cell to create a new volume in our schema. Let's go back to our Catalog Explorer and refresh the Catalog Explorer. We will notice here that our volume has been created within our schema. Let's go back to our notebook. Let us continue to the next step. Run the below cell to analyze the catalog, schema, and volume details along with the volume path and working directory path. These are the values that we have configured recently. The volume path tells us the path of the volume that we have created, and the working directory path shows us the path of the working directory where this notebook is running. If we select the workspace icon in the left side of this notebook, we will see the path that we are referring to and all the files contained in this path. Let us minimize this for now. Let's move to the next part, dataset management in Databricks. In this section, we will explore various methods for managing datasets within the Databricks environment, including uploading local files, working with Excel datasets, and interacting with Databricks volumes and workspaces. The following topics cover essential tasks to help you efficiently handle your data in Databricks. Let us load and delete a local dataset file from our system directly into a Databricks volume using the Databricks UI, ensuring seamless integration of our dataset. To do so, you will start by logging into your Databricks workspace. Then, in the left sidebar, you need to right-click and open the Catalog option in a new tab to access the Catalog Explorer page. Now, let's switch to the Catalog Explorer page. In the Catalog Explorer, you need to navigate to your volume. In the volume page, select the Upload to this volume button at the top right corner of the page. A Upload Files to Volume dialog box will appear on your screen. In this dialog box, select either the file icon or the Browse hyperlink to open Explorer. Now, select the dataset from your local system. In this case, we are going to select the movies.csv file. Our dataset is now selected. Next, in the destination path field, ensure that your volume path is selected in the below format: /volume /your catalog name /your schema name /your volume name, ending with another /. This is the path structure. We can also select the browse option and select our volume manually. We can go to our catalog, then to our schema, and finally to our volume. Now this path is selected. Let's select the upload button to upload this dataset. The target dataset file will appear in the volume after the upload. Select the file name to review its content. We can see the content of our dataset that we have just uploaded. Now let us close this view. This is how we upload the dataset to the user interface. Let us now delete this dataset from our volume. In order to do that, select the kebab menu in the right corner next to the file name. Then select the delete file option. A confirmation dialog box will appear on your screen to confirm your action. Select the delete button to confirm. Your file will now be deleted from the volume. Let's head back to our notebook. Let's move to the next step. Now let us understand how do we upload a dataset from the local storage to the Databricks workspace instead of the Catalog Explorer. Before loading a dataset into a Databricks volume, we first need to upload it from our local storage to the Databricks workspace using the Databricks workspace UI. making it available for use in notebooks and other operations. Follow these steps to upload a dataset in the Databricks volume. First, open the File Explorer in your notebook. Select the workspace icon in the inner left side to expand the file browser. Now, select the kebab menu in the file browser and then select the import option. An import dialog box will appear on your screen. In the import dialog box, select the import form field as file. Now, select the browse button and then select the dataset you need to upload from your local system. Finally, click the open button. Your dataset is now selected for upload. Now, select the import button to finalize this upload operation. The target dataset will appear in the file browser after the upload. Right-click and open the uploaded file in a new tab to review its contents. This is our dataset and we can see the values inside it. Please note that if the file is uploaded successfully, it will reflect within the file browser along with the notebook in the workspace files sidebar on the left. If the uploaded file is empty, you need to re-upload it following the same step. Let's go back to our notebook. Let us minimize the file browser. Now, let's move to the next step. Let us load a local dataset file from the workspace directory into a Databricks volume by defining paths and moving it to the target volume location. In order to do this, we have written this code. Let us analyze the code before we execute it. We are going to start by defining the name of our target dataset, which in our case is movies.csv. We need to ensure that it is available in the file browser of our Databricks workspace. Next, we need to define the path in volumes where the file will get uploaded and the path of the file within the file browser of the workspace. After defining the paths, we need to ensure if the file actually exists in the file browser. Then we need to verify if there is an existing file with the same name within our volumes. Once these two conditions are fulfilled, we will copy our dataset from our file browser to the volumes path. This is how we load a local dataset file from the workspace directory into the Databricks volume. Let us run this cell to perform this operation. Our cell has executed successfully. And if we analyze the output, we will notice that the dataset movies.csv is successfully loaded to the volume path. Let us verify the same. Let's switch to the Catalog Explorer tab and refresh it. We will notice that the movies.csv is visible within our volume. Let's head back to our notebook. Let's move to the next step. Let us load an external dataset file from a remote source, such as an S3 bucket, into a Databricks volume by defining the file URL, downloading the target dataset file, and moving it to the target volume location, enabling you to work with data from the external sources like cloud storage or external databases. Please note that in the below cell, we need to replace the text S3 link for the dataset in the external underscore dataset underscore URL variable with your own S3 link of your dataset. Get this S3 link for this dataset. Log into your Amazon console and move to the S3 bucket. This is the S3 bucket and this is the data that we are going to load in our volumes. Select the dataset to get its details. Now, in the information page for this dataset, we need to select the object URL. We will use this URL to copy our dataset from the external source to the volumes directly. Let's move back to our notebook. Now, we need to replace the S3 link for dataset comment with the actual link that we just copied. Our code is now ready. Let us analyze the code before we execute it. The first component of this code is the external dataset URL that we just defined. Next, we need to extract the name of our dataset from the URL. Next, we need to define the local path where the dataset will be downloaded from the external source. In this case, we are going to download the dataset from the S3 bucket to our file browser within the Databricks workspace. Next, we need to define the volume path where we will upload this dataset. After defining the path, we need to verify if there is already a file with the same name in the file explorer, and if we find such file, we need to remove it. Next, we will download the file from the S3 bucket into the file explorer. Then we will save the file locally. After saving the file, we also need to verify if there is an existing file with the same name in our target volume path. If we find such file, we need to remove it. Finally, we will create a copy of our file from the file browser to the volume path that we had defined. This is the entire process that we follow to load an external dataset file from an external URL into the Databricks volume. Let us run this code to analyze this operation. On analyzing the output, we will notice that the file is getting downloaded and the paths are defined. The execution is now successful, and we can notice that the dataset orders.csv is successfully uploaded to the volumes path. Let us analyze these changes. First, expand the file explorer, and we will notice that the orders.csv is downloaded here from the S3 bucket, which was the first stage of this code. Next, let's move to the Catalog Explorer tab and refresh the Catalog Explorer. We will notice that the orders.csv is now available in our volumes. Now let's go back to our notebook. Let's move to the next step. In this step, we will create a delta table from a CSV dataset stored in a Databricks volume. We begin by defining the target file path and table name. Then extract the column headers using pandas to dynamically infer a schema. The CSV file is loaded into a Spark data frame with the inferred schema, and finally, the data is written as a delta table in overwrite mode. Run the below cell to perform this operation. Our code has executed successfully, and we can notice that our table is created. Let us verify the same. Head back to our Catalog Explorer. Now expand the tables section in our schema. We will notice that our orders underscore bronze table is created. Move back to our notebook. Let's move to the next step. In this step, we will load a table from the Unity catalog into a PySpark data frame. We will begin by defining the target table name and constructing its full path within the catalog and schema. The table is then read into a PySpark data frame, enabling us to perform further data transformation and analysis. Run the below cell to perform this operation. Our code is executed. Let us analyze the output. We will notice here that our table is successfully executed and all the data is visible in the output. With this, we have completed this demo. In this demo, we learned how to manage data within the Databricks workspace using Unity Catalog's 3-level namespace. We covered catalog, schema, and volume creation, dataset uploading from various sources, and converting CSV files into delta tables. By applying these concepts, you have developed the skills to efficiently structure and manage data in Databricks, enabling better data governance and streamlined analytics. Thanks for watching.